Okay, we've got a question about a function, but lo and behold, the function has got a ln in it. Notice that this is just the same as saying f of x equals ln of 4 minus 2x. It's just another way of writing the definition of a function. We're given a domain for the function, so we want to watch out for that. Okay, but in part A, what we're doing is we're getting an inverse function. So remember, our approach to that is we start off by letting y equals, okay, whatever the function is, and then we're going to change the subject of the formula to find out what x is, and then we're going to swap x and y, and we're going to end up by saying f inverse of x equals whatever it was, and this is going to have x's in it. So this is stuff that you've done earlier in the A2 course. The difference is that this function y has got a ln on it, so probably about the first thing you're going to do is to zap that ln. You're going to be e'ing both sides, so I think you're going to be having e to the y equals something, and then carry on rearranging to make x a subject. So that should be straightforward, and oh look, they tell you what the answer is, so there shouldn't be any difficulties there. Then we've got to write down the domain of f inverse, okay? Now write down suggests that we can just do it without any work. I think you do have to do a little bit of work here, okay? The best thing to do is always to think about what the graph of this will look like, but you need to bear in mind the original domain for the original function, just to make sure it isn't a pared down one. So sketching this graph wouldn't be a bad thing to do, okay? In this particular case, okay, have they actually pared it down any more than they need to, or is there a reason why they're telling us that x has got to be less than 2? What would happen to this if x was 2 or more? Okay, sketching this graph, it's just a log graph with a bit of transformations going on that will really help you visualize the range and domain of f, and then the range and domain of f inverse will follow immediately. Okay. Then for part B, we've got to write down the range of the inverse function. Now that should be very easy, because remember, when we go from a function to its inverse, we did it here, we got down to this step, and then we said that for the inverse function, x and y change places. So input swap with outputs, range swap with domain. So really, if you want to know the range of an inverse function, all you need to know is the domain of the original function, which is here, but then you need to make sure you describe it correctly. Remember, a domain is always described using x, but a range is always defined talking about f of x, or in this case, because the function is f inverse of x. So make sure you use that symbol with the range. Okay? And then for part C, it says sketch the graph. Now I suggest you start with a sketch graph, maybe even for the original function that you were given for the f, okay, but certainly when you come to think about the range and domain of this, and all will become clear. So do this graph sketching thing in part C, I would actually do before you do part B. Okay, don't forget to do this bit, coordinates of the points of intersection with the x and y axes. So for the x-intercept, you're going to solve for y equals 0, and for the y-intercept, you're going to take x to equal 0, okay? So x equals 0, substitute it in, this will be just a value, and then to solve y equals 0, if you want this to equal 0, you're going to have to rearrange, and it's a normal thing. You're going to strip down to this e to the x, and then you're going to use a ln to find out what x is. Okay, hope that helps.